Hello, today we will learn about distributive property and we will see some examples. So, distributive property is quite interesting. So, if you have a number, let's call it x, outside a parenthesis and inside the parenthesis you have any kind of addition. So, for example, y plus z, but you could have as many terms as you want as long as it's only additions. You are only adding those terms, then you could actually say that that is equal to x times y plus x times z plus whatever is in the middle. But also, like, remember multiplying all terms by x. And x times the y. So this is the distributive property, and we will see some examples. So this is a very simple example. We have 3 plus 11 and all of that multiplied times 5. Using distributive property, you can think of it as being multiplied by each one of the elements and just like being carried there. So you have 3 times 5 plus 5 times 11. And so this is equal to 15 and this is equal to 55. And if you add those two values, you get 70. So now, we got the answer, everything is fine, but let's just make sure that our answer is actually right and that the distributive property works. So what we can do is solve it some other way and make sure that we get the same answer. So as you might recall, we used substitution before to do things similar to this. So if we add 3 and 11, we get 14, and if you multiply that times 5, you actually find out that it is equal to 70. So you get the right answer. Very well, congratulations. So now, we can use actually the distributive property to do mental math. And we can use it in reverse. So for example, you have 12 times 104, and at first you will think that you cannot do it in your head, or you must need a calculator, right? But no, actually, you can divide 104 into 100 plus 4. And you know that you multiply that times 12. And now, using the distributive property, you can do 12 times 100 plus 4 times 12, which is actually very easy to calculate. You get 1200 plus 48. And so your answer is 1248. Now let's do one last example with variables and algebraic expressions. And so it works exactly the same way. We just distribute the 4. And so we have 4x plus 4 times 7. So about the confusion. And so this is equal to 4x plus 28. And we use the distributive property. Now, thinking of distributive property, we can reach a conclusion that we can combine like terms. What do I mean by that? I'm going to show you with some examples which I think would make everything easier. So, in this case, we find that a lot of the terms are being multiplied by b and some with b squared times b squared. And so we can combine like terms. So right here, we could actually bring out the b in this case, and then we leave alone whatever we left. So as you might recall, the distributive property is like that, and so you distribute like that. But what would happen if actually kind of we had xz plus yz, and we actually wanted to have the arrows in the opposite direction. We will be left with x plus y and then times z. So working the distributive property in reverse. So this is exactly what we're doing. So we're bringing out the b in this case, and so we are left with 2/3 plus 2. And then here, as you might know, b squared is actually b times b. And we could actually like add it to whatever is inside this parenthesis as plus b, because we took out one of the b's and we are left with b by itself, and then plus b over 3. This is one way of doing it. However, since we still have b's here, we could think of it another way, and that could be as looking at them as if they were two different things, so we must add them. And for these two, we will take out b squared as a whole, so not just b, but b squared, and we're left with 1 plus 1/3. And now it's just simple addition, so let me just copy it here. Right? 2/3, not 1/2. I apologize. And so we just do addition. 1/3 plus 2/3 is equal to 1 plus 2. This is equal to 3. So we have 3b actually. We can just get rid of the parentheses. No need if it's only two values that are being multiplied. And then here we have 4/3. So we're left with 4/3 b squared. And you can see how much we simplified. We had this very long expression, and we just made it really small, and they are equivalent.